Hi guys, I welcome you all to today's class. In this class, I'll be walking you through everything you need to know as far as the basic differentiation is concerned. Because in calculus, there are two aspects of it. We have differentiation and as well as integration. But today, I'll be walking you through the journey of differentiation. Let's get started. So what do you mean by the word differentiation in calculus? Differentiation in calculus, it means the rate of changes. So if you consider from the equation of a straight line, the equation of a straight lines, which states if you have y minus y1 equals to m into bracket of x minus x1. So we have the equation of straight line given that there is a small increment in y and as well as there is a small increment in x. And where this m is known as gradient, divided through by this x minus y, then we have m equals to y minus y1 divided by x minus x1. But this y minus y1 and x minus y1 equals to change in y divided by change in x. So as far as the m here equals to change in y divided by change in x. So we are dealing with derivatives. So the m here you see here is known as the gradient. And as far as y increase, then x also increase. We are dealing with the derivatives. What are the things that make y changes and what are the things that make x changes? You see, let's say we have the value of y to be like, let's say 3. So as far as there is a small changes in it, it means that y is going to reduce in value. You know, we are subtracting, we are not adding. So y is going to reduce in value. So that is what brings about the derivatives. And as far as something is decreasing, we are dealing with differentiation. So which means differentiation means the rate of changes or decreasing in the values of a particular variable. But how are you going to know that a value is decreasing? So we consider two different aspects. It's either the power of that variable decrease or the quality of that particular function decrease. So that's what's in by the word differentiation. So in some cases, you might see m and someone call m derivative. So the person doesn't make any mistake. So they are still the same thing because derivatives also known as the gradient. Now, so let's see the basic and the standard formula of derivatives. So as far as this formula is known, so there is no problem that you cannot solve in differentiation. So here is the powerful formula for the derivatives. So suppose you have y equals x raised to the power of n. So there are two sides here. We have y and we have x. So the x here is known as dependent variable. So the y here is known as dependent variable, while x is known as independent variable. So the independent variable here, it has the power of what? The power of n. So which means n can take anything. N can be 1, n can be 2, n can be 3, and as well as n that we are given. So now how are we going to know the derivatives for this particular for this particular two variables? They are the dependent variable and the independent variable. So it's very simple. So since the symbol of these derivatives is given as d over the x, so since we are differentiating with respect to x, so we take it as d over the x of what? Of this particular variable. Then we write it as x raised to the power n equals to, so this value is going to decrease, but this is what I'm going to do. You take this n back, then you subtract 1 from the power of that n. So here we have nx raised to the power of n minus 1. So here is the standard formula for the derivative. But from this assumption, I said y equals to x raised to the power n. I use x raised to the power n here, which means I can replace this x raised to the power n with this y. So therefore you have dy upon dx equals to nx raised to the power of n minus 1. So here is the standard formula for differentiation. But this dy dx can still be f of x. Sorry, f prime of x. So this prime indicates that we have differentiated this particular function. So either you have it as dy dx or you have it as f prime of x. So you are still dealing with differentiation. So here I can still agree that dy over dx of this equals to f prime of x equals n x raised to the power of n minus 1. So this is another dimension of writing the derivative. So another person can still decide not to use dy over dx or f prime of x. So since we are dealing with y here, okay, I can call it y dot. The y dot here still the same thing as n x raised to the power of n minus 1. Note that if you have something like y equals to nx raised to the power of n minus 1, so this is not a derivative. So if you want to know that it is a derivative, it must come in how many dimensions? In 3 different dimensions. Either you write it as dy over dx, or you write it as f prime of x, or you write it as y dot. So all these one, they are derivative. So y is not derivative here, so this is still a function. You have not differentiated this. So you might be given a question like this, is not differentiable at this moment, but as far as something like this, which is dot or f prime of x or derivative dy dx, so it means you have differentiated that particular function. So if this is clear, let's proceed to another thing by consider some basic examples of differentiation. But before that, note that whenever you have a constant value, derivative of any constant value equals to 0. You must be differentiating with respect to the given independent variable. You know, I call this x independent variable, so we are differentiating with respect to x. But if you are given a constant value, so you cannot differentiate the constant value. So the constant value differentiation equivalent to 0. As far as you have a constant value equals to 0. So don't forget that. Keep that in mind. So let's see the examples of different functions. So let's see how to differentiate them. So the question can come like this. You can say obtain the derivative of the following So let's say the first one is, we are given y equals to x raised to the power of 3. Let's say we have b, y equals to x squared plus 1. Let's see how to go with this simple differentiation. This particular function is known as polynomial function because the highest power here is 3. So this particular function is known as quadratic because the highest power here is 2. So how can we differentiate it? So we go by writing the solution. So the first one, which is a, is y equals to x raised to the power of 3. But keep this formula in mind. So the y upon the x, equals n x raised to the power of n minus 1. So if 3 here is the n, so we take 3 back, then we subtract 1 from that 3. So therefore, the y divided by the x for this particular variable, so equals to, take 3 back, we have 3, we write this x, then subtract 1 from this, so that is 3 minus 1. Here the y divided by the x equals to 3x raised to power of 2. So it means that you have differentiated this. How do you know that you have differentiated this? Because the initial power of this particular variable is 3. Then after you differentiate it, it's reduced to 2. So which means differentiation has taken place. Now let's see the second one. The second one, which is y equals to x squared plus 1. So to differentiate this, so we take derivative of it and the derivative of this as well. Okay, let's see the y divided by the x. So by applying the same thing, take these two back, then subtract 1 from it, we have 1. But here is the constant value. We have 1 there. So 1, if you differentiate 1 here, is going to be equals to 0. Because we are differentiating with respect to 1, with respect to x, not with respect to 1. So I didn't put the y over the 1 here. And even if you write that, it doesn't make any sense. So we must be differentiating with a particular function, with respect to a particular function, not a constant value. So differential of this constant value equals to 0. So therefore, the y divided by the x equals to 2x. So we differentiate with respect to this equals to 2x. But okay, let's say someone asks you to find to find how this one becomes 0. It's very simple. So I can manipulate the value of x, but don't forget that any number raised to power of 0 equals to 1. Okay, so if this value of x is equivalent to x raised to power of 0, which is still 1. So if you take 0 back and you subtract 1 from 0, so the power here will become minus 1. X raised to power minus 1, but don't forget we have 0 at the back. If the 0 multiply all those numbers, we still go to arrive at 0. So that is why the derivative of any constant value equals to 0. So now the next thing is we will consider the advanced derivative of some let's say quadratic, trinomial, polynomial, and others. So I will consider just 2 examples for us to understand deeply more about this. Okay, suppose we are given this particular function. If y equals, suppose we are given, consider this as example number 3. Let's say y equals to x raised to the power of 3 plus 2x squared plus 4x minus 4. So we have to differentiate this. So this is very simple, and this is polynomial function. So to obtain the y, the x, just apply the standard and the acceptable formula, which is ns raised to the power of n minus 1. So nothing is changed here. So it's just like we have combined different variables together. Okay, let's see how to obtain the y, the x. So the y, the x for this one, so take this 3 back, we have 3x, subtract 1 from that 3, that is 2. Plus, here, we have coefficient of x squared, which is 2. So, when taking this thing back, so 2 at the front of this x, we multiply this 2. So, making 4. Here we have 4x raised to the power. So, you subtract 1 from this, we have just ordinary 1 plus. Now, we have 1 at this stage. So, if you multiply 1 with this 4, so we are still going to have 4. So, we subtract 1 from here. Here we have 4x raised to the power. 1 minus 1 equals to 0 minus 0, because the differential of any constant equals to 0. Now, so we have the y divided by the x equals to 3x squared plus 4x. Now, if x raised to the power of 0 equals to 1, then 4 multiplied by 1 is still what? It's still 4. So which means the derivative of this thing equals to this. Okay, let's see example number 4, be the last one here. If f of x equals to 1 divided by x plus 3x squared minus 5. So to do this, what we are going to do is let's transform this. Let's write this thing in form of exponent, not in form of fraction again. So if you have 1 divided by s, it's still the same thing as s raised to the power of minus 1. So which means I can transform this as f of x equals s raised to the power minus 1 plus 3x squared minus 5. So now let's differentiate this. So we have f prime of x equals, so we take negative 1 back, negative 1. So subtract 1 from this, we have negative minus 1, that is minus 2, plus multiply this with this, we have 6x, and the differential of any constant value here is still 0. So here, the f prime of x here is negative s raised to the power this plus 6x. So this is how to differentiate a if you have a quotient value like this, I mean the function in form of fraction. So we first transform that one into the exponential form, then we differentiate. Okay, if all these things is clear, the next thing I'm going to do is I will show you. Okay, let's see one more example for us to understand much more better what we mean by the derivatives and how to differentiate. But you might get confused in some stages that someone gives you a particular function that is not part of what you're asked to differentiate. So to do that, it's very simple. So just follow this step. Let's say you are given if y equals to 2m squared. Then the question says find the y divided by the x. But the function given here is m, not x. So automatically this m here serves as the constant value. So to obtain derivative here, so just say the y divided by the x equals to is 0, because this thing is constant, is not related to the particular independent variable that we are asked to differentiate. So the derivative of m here equals to 0. So this is what I want to show you, because some people might try to convince you guys that okay, differentiate this. So as far as it is not related to what we are giving here, then we are good to go that this thing is a constant. But if I change this one to m, yeah, so this thing is differentiable now, because we have m here and we are asked to differentiate with respect to m. So with respect to m here, it means that this thing become 4m, and you change this one to m as well. So the y divided by the m equals to this. So it is not necessary for this one to be y, it can be anything. But as far as the derivative goes along with both dependent variable and independent variable, then we are good to go on the differentiation. So now you need to know some standard derivative, I mean some basic derivatives that if you use some rules which we might cover later in the in my next video. There is a way of proving them, but I just write this as you guys can memorize them and be using them in a particular question. But if you need the proofing of all these things, so there's going to be another video that will show everything you need to know about some important functions in a differentiation. So let's see, there are some standard derivatives. We call these standard derivatives. So the first thing is, let's say we are given y, which this y is also known as f of x. So we want to obtain the derivative of this f of x. So you write it as the y divided by the x. Okay, the first thing I want to show you is, let's say we are giving derivative of s raised to the power n. So it's very simple. We have it as nx raised to the power of n minus 1. So that is the differentiation of it. Okay, number 2. Let's say you have the derivative of exponential x. So it's still the same thing as exponential x, provided that the coefficient of this x equals to 1. But let's say the coefficient of x changes. Let's say we have kx. So k can be anything. It can be 1, it can be 2, it can be 3, it can be negative as well. Even it can be fraction. So you take k back, we have k exponential of kx. So this is how to differentiate this. Let's see number 4. If someone asks you to differentiate log of x, provided that this thing is in form of e, so we are going to have it as 1 divided by x. So I can still write this thing as ln of x. Okay, let's see number 5. If this thing, let's say we are given 2 raised to power of, or let me just call it a raised to power of x. Someone has to differentiate this. So what I'm going to do is a raised to power of x ln of a, or we can call it the log of a. So let's say these are the standards. So I'm going to rub it now because of the just for you to get it clearly. That's why I'm dividing the board. So let's see the next one that we need to know as far as the standard differentiation is concerned. Okay, I'm going to move to the aspect of trigonometry. So let's say if this one is sine x, the derivative of sine x equals to cos x. So if this one is cos x, the derivative of cos x equals to minus sine of x. So let's say we have tan of x, the derivative of tan x equals to sec square x, and someone asks you to differentiate sec x equals to sec x tan x. So let's proceed. If someone asks you to differentiate cot x equals to minus cosec square x. So here is another standard derivatives that we need to know as far as this differentiation is concerned. So I still proceed because we still have more. Yeah, we have more of the standard derivative that we need to know, even if we don't know the proofing of it. So let's know it offhand. Okay, another one is if someone asks you to differentiate sec x. Oh, sorry, if someone asks you to differentiate, I think I wrote sec x before. Someone asks you to differentiate cosec x. Yeah, the cosec x equals to cosec x cot x. So here are the okay, let's see something as well. Let's say we are given sine of hx, so which is hyperbolic. So sine of hs is still the same thing as cos of hs. And if cos of hs, so it's still the same thing of sine of hx. So here are the things that we need to know as far as the standard differentiation is concerned. So let's see some examples how to differentiate this in a given question. So the question I say, find the derivative of this following function. So let's say for number 1, if you are given y equals to x raised to the power of 3 plus sine x plus log of x. So to differentiate this is very simple. So just write the y divided by the x equals to, so by differentiating this, we are going to have this as 3x squared plus, but the derivative of sine x equals to cos x plus the derivative of log x from the standard one equals to 1 divided by x. So which means we have differentiate this particular function. So I still consider another example here. If you are given this another example as well, that you should find the derivative. So let's say number 2, if y equals to 1 divided by x minus cot x plus cos x. So to differentiate this is very simple. Just transform this as x raised to the power minus 1 minus cot x plus cos x. So I will transform this just for us to get confused. So here we are going to have the y over the x. The y over the x equals to minus 1 x raised to the power of minus 2. But the derivative of cot x is still the same thing as what? Minus cosec square x. While the derivative of cos x is minus sine of x. Okay. I can find the final answer. The final answer for this one is going to be minus x raised to power minus 2. So negative multiplied by negative, that is positive. Cosec square x minus sine of x. And you can assume this one to be 1 minus 1 divided by x squared plus cosec square x minus sine of x. So this is the y over the x of this particular function. Thank you guys for watching. If you are new to my YouTube channel, try to subscribe and for you to be aware of when I drop a new video. Calculus is very nice. It's your friend. Try to leverage it. But don't go yet. Before you go, let's test our ability on whether we understand this topic very well or we don't understand it. So I'm going to give some question here which you are going to drop the answer in the comment section below. I will reply to every messages. Try to solve the question and put it down in the comment section below. Don't forget to like this, like, share and subscribe to my YouTube channel. Thank you very much. So let's see the first thing you are going to do as part of the let's say assignment. Okay, let's say we are giving number 1. If y equals to sine x plus x raised to the power 3 minus x raised to the power 2 plus cos x. Okay, let's say number 2. If you have f of x equals to a raised to the power of x plus c. Okay, number 3. Let's say we have y equals to exponential of 2x plus cos x. And then number 4, y equals to exponential minus 2x plus 3x raised to the power 5, okay, divided by x minus 4x raised to the power minus 2. Thank you for watching. I will see you